Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
So for this question, they already told you this is an ideal op-amp. Ideal means you can assume the gain is infinite, you don't have to worry. So what is the output? You write down the formula. V out equals to infinite. Now V plus minus V minus, your V plus is V2. So you take V2 minus V1. Understand? V plus minus V minus. Okay, now up to here.
Yeah, I thought it's the second one.
Okay, now first part very simple. Okay, so then for the next part, if your V1 is more than V2, so you substitute if your V1 is more than V2, you get positive or negative?
V1 is more than V2, negative.
So you get negative 9 volt saturation now. But if V1 is less than V2, then it's positive 9 volts now. So for this question, if you want to see what happens to the red or green LED, right? So all you have to do is remember your V minus is connected to 5 here, V minus is connected to 3 here. But the V plus for both is connected to your V in. So if you put in 2 volts, so you substitute your V in as 2, that means the V plus here will be 2, V plus here will be 2. So calculate the output here will be V plus minus V minus. So 2 minus 5 is a negative, so your output will be negative 9 volts. You need to use the values from the previous page. And for this part, 2 minus 3 is also negative, so your output is negative 9 volts. So since it's negative 9 for both, and this is 0 for bottom, so current cannot flow, so both are turned off. But if the input changes to 4, so 4 minus 5 is negative, so you still cannot flow, but 4 minus 3 is positive already, so you get positive 9 volts output. So positive 9 volts current can flow, so then the red will light up. So if it's 6 volts, then 6 minus 5 is positive, 6 minus 3 is positive, so both will be positive 9, so both will flow, so both will light up. So what is happening here is basically you have 2 different temperatures and 2 different resistances. So let's find out what happened to the 2 LEDs, which one will light up, whether this red or green. So at 16 degrees, first you must find what is this potential, because that will give you your V minus, and then at 18 degrees you also need to find this potential, because this is connected to the thermistor, so you need to find your V minus. Now, but before we do that, you see your V plus is connected in between the 2 resistors. So your V plus is this potential. So this one is quite easy because this is 2 volts, this is 0 volts. So each resistance will take 1 volt, because equal resistance. So the potential is 1 volt. So your V plus is fixed at 1. But your V minus, you must find the PD from the 0 side. That means you must find here. So therefore, at 16 degrees, 2100 ohm. So what is this PD? So you must take this resistance, which is 2000, over total resistance 2000 plus 2001 times total voltage, then you get this. Repeat it for the 18 degrees where your resistance is now 1009. So repeat it, then you get these 2 values. So then your V out, for this particular case, your V plus minus V1, V minus, 1 minus the V minus, right? 1 minus this value is a positive. So your output is positive 5 saturation. So positive 5 red will light up. But for this side, if you substitute your V minus as 1.026, then you get negative. So negative means your output will be negative 5 volt saturated. So negative 5 means your G will light up. But don't forget to tell them that R turns off first. So you must say R turns off and G lights up, because if you don't say R turns off, that means you are saying that R lights up and G lights up, means both light up. So you must say R turns off and then G lights up. Now how do I know whether it's AC or DC? Like some students ask, right? So if it is AC, they must tell you frequency. If they don't mention about frequency, they just tell you this voltage, that means it's definitely direct. So the thing about comparator circuits, right? Most of the time, the output is just saturated because your gain is just too high. So, but saturated output doesn't mean it's useless, because ultimately we only need either positive or negative. So we don't need to have fluctuating output. We only need either a positive saturation or negative saturation, because your output is either on or off. So you don't need to have variable output. So this is actually found in a tutorial because it's 1996. So what this student is trying to do is he wants to see whether he wants to monitor from a distance, that means far away from the door, whether it's open or closed. So now this is a comparator circuit, even though it looks a bit more complicated because you still have two inputs and you don't have a feedback. That means you don't connect output back to input. So it is still called comparator circuit. So what is the function of resistor R here? So actually there are two functions of resistor R. Now the first thing is when the switch is open, right? Now let's see what happens. If this is 9 volts, this is 9 volts, this is 9 volts. This is -9, so it's -9, -9, right? Now when the switch is open, what is the potential here? So many people told me, oh, 9 volts cannot be 9 because the switch is open, so it's not connected. So this is not 9 volts. They say, oh, this is -9, this is 9, so this 0 must be in between. Also wrong, because there is no current flowing here. No, because you see, current is supposed to flow from here to -9 if the switch is closed. You open the switch, current cannot flow already, correct? So therefore, there's no current in the resistor R. Is there any potential difference? No, right? Because PD is V equals to IR. No current, no PD. So no potential difference, but it's still connected. No, it's just that no current is flowing. So this becomes -9 volts. So what is the function of a resistor R? It connects your V minus to this point. So that means the function of resistor R is when the switch is open, it gives your V minus -9 volts. That's the first function. So you write down there, when the switch is open, it holds the potential at -9 volts. Okay, when the switch is open, it holds V minus, it holds V minus at -9 volts. Okay, when the switch is open, it holds V minus at -9 volts. Okay, now after that, people ask me, right? So some students will tell me, without the R, right, let's say I want to save money, 40 cents or 50 cents one resistor, I just use a wire. If I use a wire, right, across this side, instead of a resistor, I can also be following -9, right? So why need a resistor? Because the resistor is a second function. If you close the switch, current will flow, right? Can you see this way it flows? Now it cannot flow in here because remember infinite input impedance. It cannot flow here, infinite input impedance. Current has to flow this way from the two batteries, one round here. Now if this was a wire, can you see you'll be shorting the circuit? With a resistor, you are preventing the shorting of the circuit. So that's the second function of resistor R. So you must say it prevents shorting of the circuit when the switch is closed. So the next part, deduce the state of the LEDs A and B when the switch is closed. Now I want to explain to you what happens. So when the switch is closed now, switch is closed, current can flow. So what is the potential here? 9. Do you close the switch, this will be 9 as well. So that means you must remember, close switch, your V minus is +9, open the switch is -9. So your V minus, I know is +9, but what's my V plus? Now this is a trick. Can you see this is -9, there's a cell of 1.5 volts, that means this side is negative, this side is positive. That means this side must be higher than this by 1.5. So -9 increased by 1.5 is -7.5. Because many people just see the voltage here 1.5 and then just write here 1.5. You cannot do that. Because this is the potential here. So this is -9, increases by 1.5 is -7.5. So you must calculate the V out using this formula now. 10 to the power 5. Now why I use 10 to the power 5? Because they didn't tell me it was an ideal op-amp, so I assume it's a real op-amp. So V plus is -7.5. Minus V minus is +9, so minus +9, so it's -9. So I will get negative value, so it's negative saturation. Now, if the output is -9 here, which LED will light up, A or B? Now, if the top is +9, bottom is -9, can current flow? Can, right now. So this A sure light up or not? Then people ask me, if this is +9, -9, it flow here. This is also -9, can it flow down or not? That means go one round like that. Now, if current flows across a resistor, there must be potential difference, right now. So this is negative 9, positive 9. What's the potential difference? 18 volts. So there's a difference. But this is negative 9, negative 9. Is there any PD or not? No. So there cannot be any current. Because got current means must have PD. Got PD means these two cannot be the same. So since these two are the same, current didn't flow here. So where did the current come from? It came from the 9 here, pass through here, go down here to negative 9. Because it actually makes sense or no, if you talk about current behavior, after flowing here, can you see to reach here that two paths, one is here and one is here? This side got no resistance, remember, zero output impedance. This side got resistance, wouldn't it just short and go this way? That's how it works lah. So when what happens to A and B when S is open? So when it's open, don't forget your V minus is negative 9, or your V plus doesn't change. So now you calculate 10 to the power 5, negative 7.5 minus negative 9. So you get positive 9 output. Now positive 9 output, current sure can flow from positive 9 to negative 9. So B will light up. But what will happen to A? Will it still light up? Now, positive 9, if current does flow across a resistor, there must be PD. But since these two have the same potential, means no PD, current didn't flow here. So then people ask me, where did the current come from? So current came from here to here and then down here. Because when current comes here, it has two paths to reach here, either through resistor or no resistor. Of course, it goes through no resistor. It comes back here. So you must tell them, show them this, and then you must tell them, therefore A will turn off and B will light up. Now for this question, they ask you to show the ratio and time t of the output potential. Now this is a comparator, so you can first write down the formula. V out, okay, equals to, now this is supposed to be an ideal op-amp lah. Alright, so let's say you put infinite. Now your V plus is V2, your V minus is V1. So now they also told you that your V2 is kept constant 1.5. So this one is 1.5 minus V1. Now, how do you plot your output graph, your V out? So you will notice they were also very kind. They drew the V2 for you here. Now you will see that whenever your V1 is less than 1.5, your output will be positive 5, right? Because your saturated values are 5 and negative 5. But your V1 is more than 1.5, then you get negative 5. So you look at this portion here. Can you see this portion, your V1 is less than 1.5? So less than 1.5, you saturate at positive 5. Then can you see this portion here? This portion, your V1 is more than 1.5. So this portion must give you negative 5. So from this portion must give you output negative 5. Then same thing, from here to here, your V1 is less than 1.5. So the whole thing here will give you positive 5. Then this one more than 1.5, so negative 5. So you just keep drawing this on here. So next part, if you want to connect two LEDs R and G, they want R to emit longer time for G. So do you look at this, do you realize 5 volts is longer time is from here to here, is longer time than for negative 5 volts? So that means if your R must light up longer than G, that means at 5 volts, positive 5, your rate must light up. So therefore you join the R downwards, point downwards. So when it's positive 5, current will flow. So R will light up for a longer time. But when it's negative 5, then current will flow this way. So green will light up for a shorter time. Okay, so that's how you draw. Now, state suitable sensing device for the detection of change in temperature is what? Thermistor. Pressure changes in the sound wave? Piezoelectric transducer. So state the value of the output potential for an input potential of 0.5 volts. Explain your answer. So what is actually happening here is your V out is equals to infinite. Now can you see your V plus is connected to earth? So that your V plus is 0. Then you must minus your V in, so that is your equation. So in other words, what will happen to your output when the V in is 0.5? So you get negative saturation, right? Correct. So I want you to write down this formula. Then you write down there V out equals to negative 5 volts. V out equals to negative 5 volts due to saturation. Or maybe you should write down this first, V out equals to infinite, V plus minus V minus. Then you tell them V plus is 0 volts because it's earth. So you write down this first, V out equals to infinite, V plus minus V minus. Then you tell them V plus is 0 volts because it's earth. Then only you tell them, therefore V out is infinite, 0 minus V in. Therefore the output will be negative 5 volts due to saturation. Okay? Right, that's all. So for this graph, don't forget what I told you just now. So now your V in is not fixed. Your V in is changing from how much? From 0, from 2 to negative 2 to this. So that means you don't need to use 0.5 anymore. So when you don't have to use 0.5 anymore because your V in is changing, so very simple, when your V out is equals to infinite 0 minus V in. So when your V in is positive, wouldn't you get a negative output? And then when your V in is negative, would you get positive output? So your graph is actually just inverse only. That means when it's positive, you will saturate at negative 5. Here. Then when it's negative, it will saturate at positive 5. Somewhere here. Okay. And then when it's positive again, it will saturate at negative 5. Okay, that's all.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.